Well, my agenda tonight is pretty simple. I'm going to talk about two things: the Tuna-10S transmitter and the tiny SA spectrum analyzer. I have a picture of a tuna up here so you know what they look like before they're put into a tuna tin can. But I'll show you a couple of tuna tin transmitters after this. Okay. Most of us old hams remember radios with vacuum tubes. I got started in radio in the 50s, and but I learned about transistors real soon, and I thought it was pretty amazing that you could replace a vacuum tube with a piece of sand, a little speck of sand. And so I pretty soon got away from the vacuum tube receivers and transmitters that I built as a kid and moved on to transistorized gear. The hollow state age came before solid state, and then the analog age came before the digital age. The tuna tin name comes from an article in 1976 in QST. Doug DeMaw, who's a legend to us, some of us older guys, he wrote an article called Build a Tuna Tin 2. It was called the Tuna Tin 2 because it had two transistors, and hams at that point were still leery of transistors. He wanted to get hams to start building their own gear and build the gear with transistors. So he came up with this idea of this little transmitter. Here's a picture of it. It was built in a tuna tin can. I'm sure he washed it out before he drilled holes in it and put connectors on the side and so forth. And then he designed a circuit board.
We still just see the fish.
Oh, really?
Yes.
You'll have to reshare a different.
Thanks for telling me that.
Or share the whole desktop.
New share I have to go to each time I do this?
If you share your desktop, then we'll see whatever you've got on your screen.
Okay, well, how do I do that? Not on the screen.
Well, go ahead and unshare what you've got, and then you should have a full set of choices.
Okay. All right. I have to stop that share and go to a new share. Okay. Are you seeing the tuna tin now?
It's still coming up. Yeah, we got something now.
Okay. So you're seeing build a tuna tin too?
Yes.
Yep, that's good.
Okay, good. Okay. So he wrote this article. He designed a little transmitter and a circuit board that would install on top of a tuna tin. The circuit was this one. It was a 2-transistor transmitter, and it had 3 inductors. Hams in those days and hams today are a little scared of inductors and winding their own coils and so forth. So what Doug did was he went to Radio Shack and he found 3 chokes that were on sale at Radio Shack, and he modified those 3 chokes to be the inductors for this transmitter. And he made it easy for hams to go out and buy the parts at Radio Shack and build the transmitter. So that's basically what the tuna tin was all about. Okay. navigating all of this is a bit of work. So I guess I have to stop the share again and start it each time I want to do something, huh?
Only if they're different applications.
Okay. All right. That really isn't what I wanted to do. Hold on. Screen sharing has stopped at the, okay.
If you share your desktop, then we'll see whatever you've got on your screen, if that's easier, rather than going backwards and forwards.
Okay, well, I have to find where it says shared desktop, I guess. Do you see the Tuna 10S?
Yes. Yep, that's good.
Okay, all right. In December, the QST came out and I saw an article called the Tuna 10S, a bare bones synthesized QRPP transmitter. And this was the first page of it. What we're looking at is a Collins 75S3, a receiver on the bottom with all kinds of vacuum tubes in it. And for those that are interested, it was a permeability tuned receiver, just like the tin-ear receiver that Phil and I built. And I handed out 3 circuit boards to other club members to build the tin-ear receiver. Anyway, sitting on top of this big boat anchor, which we didn't think of as a boat anchor in those days. I mean, that was what the well-heeled hams had. The rich hams had those guys, and that was the state of the art. That was the gold standard of receivers and transmitters in that age. This particular receiver came out in 1967. And sitting on top of it is a Russian cookie tin that has the Tuna 10S transmitter inside of it. Bob Fontana wrote this article. He designed the transmitter, and and I read that article, and I thought that it would be a good project for some members in our club. And one of the things I liked about it was that it combined the analog and the digital era into one transmitter, one circuit. And it would be an opportunity to get people who hadn't had any experience with digital gear and Arduinos and so forth to get their hand in. And so I thought that we could have a project to build this transmitter. I contacted Phil and I said, what do you think, Phil? And I think that, you know, if we got some people to build this, that we could probably coach them through Zoom sessions to actually get it built. And wasn't real enthusiastic. He said, well, that sounds like an idea. And then I work 40 hours a week, so I just periodically, I asked Phil, you know, what do you think? Still think that might be a good idea? And he says, oh yeah. And he didn't tell me what he was doing. Well, this particular transmitter has a digital section and an analog section. The digital section is composed of these 4 modules. U1 on the left-hand side is an Arduino Nano. It's a computer that runs software. Attached to that, on the right side, U2 is this OLED module, which is a display. And then to the right of that is the SI5351 clock generator. And below that is an encoder. The encoder is like a pot potentiometer. You turn a knob and you can pick a frequency. And the Nano then displays that frequency on the display, and then it tells the clock generator to send a signal out, an RF signal out at that frequency. To the right to a transmitter board. So that's the basic block diagram for the digital half of this transmitter. And then further down in this article, it shows you the analog half. The analog half of the transmitter is really quite simple. The signal, the RF signal coming from the clock generator comes in from the left side, it comes to Q1, a transistor, a MOSFET transistor, to which the source pin is connected to a key. When the key is pressed, that causes the transistor to conduct and send the signal on to a bandpass filter to the right, and then on out to the right through this P2 connector to an antenna. So that's a pretty simple circuit. I thought both of them were simple circuits. Combined together, we could build a CW transmitter that will put out some 600 milliwatts. So that I'll switch to another image here. I'll stop the share. Trouble is, how do I share get my whole screen up here?
On the share screen button, when you press it, there should be like two options. Like you should see like desktop 1 and then other apps. So if you pick desktop 1, then you can share your whole desktop.
I see screen.
Screen, okay,
I
yeah.
do not see screen. Okay, share that. Okay. So now you're seeing my screen. Back to the same image, right?
Yep.
Yes.
Yeah, that's good. We see the whole desktop. Yep, you're good.
Okay. Okay. Okay.
Okay.
I'm bringing up a photo of the Tuna 10S transmitter here. I'm trying to anyway. Okay, do you see it now? This is a picture of the Tuna 10S transmitter.
Yep, it's good.
Okay. We're looking down into the transmitter as it was designed in the article. And there are two circuit boards. On the left-hand side is the digital board. On the right-hand side is the analog board. There's a lot of wiring. There's a little display on the front of this tin that shows a frequency. To the left of that is a knob that's used to choose the frequency. To the right of the display is the plug-in for the key. And to the right of that is a toggle switch to switch the antenna between the transmitter and the receiver. Looking at this, I don't like the looks of this thing. I'm saying, other people are going to build this. We need to simplify it, and we need to reduce the cost of it and improve it. Engineers never look at anything and say, that's great. They generally say, oh, that's great, except I can improve it. And the things I wanted to improve were to reduce the size of it, go from 2 boards to 1 board, eliminate all that wiring if we could, put all the connectors on a board. And then we had a big problem that in the analog board, there are these things called bobbins. these little pink things are bobbins that coils were wound on. There are 3 of them there, and there's 1 more over here. So there's 4 of those bobbins. And when the article came out, I went to the website to find, where I could buy those bobbins, and the company that offered them no longer offered them, and neither did anybody else. So those bobbins are unobtainable, and we didn't want to use them anyway. We wanted to use the modern toroids that we use on all our other projects. Another problem I saw is that they were using SMA connectors. And SMA connectors and cables are expensive and are probably not necessary, I thought. So, and the receiver transmitter switching was rather crude with this toggle switch here and required a bunch of wiring. So I told Phil what I thought, and Phil said he'd think about it. And time passed, and next thing I know, Phil's saying, well, hey, I got a prototype. Okay. So now I want to show you Phil's prototype. Do you see Phil's prototype now? It's 2 boards.
Yep, that's good.
Okay. On the right-hand side is a prototyped version of the digital board. And on the left is the prototype that he built with a piece of copper-clad printed circuit board for the analog side. Together, it's a complete transmitter. Not all hooked up to run at this point, but that's what Phil turned out, and he did that in no time at all. I think he showed this to me at Christmas time. I got the article first week in December, and I think by Christmas he had this operating. So, and he said he was getting 600 milliwatts out of it. So, which is about the best that can be expected. So, anyway, that was his prototype. I didn't say anything to him, but I went off and did some prototyping too. I'm bringing up another image here. This is my version on a prototyping board of the digital board, the digital half of this transmitter, hooked up to my oscilloscope, showing the output of the digital signal or the input to the RF amplifier. You see that?
Yep, that's good. Yep.
Yeah, you see it? Okay. This trace on the screen here looks like the waves out on Folsom Lake under a storm. They aren't sine waves, but they're pretty close and plenty good enough for this particular transmitter, the purpose of this transmitter. John Kim sails out on Folsom Lake, so he knows what waves look like. I don't know if he's tuned in tonight, but anyway. So that worked for me. I also did a prototype of the RF amplifier, the analog half of this transmitter, and I had a problem with it, and I told Phil about it, and he made some changes. And then finally, Phil came to the board that some 21 of you have in your own possession at this point, and have may or may not have started working on. But here's the final board for the Tuna 10S transmitter. It's a single board. Everything is on the board. There's no wiring, extraneous wiring. All the connectors are on the right-hand side. All the controls are on the left-hand side. And Phil made various changes and improvements to it, and turned out to be a good little transmitter. So I think I've shown you nearly everything here except my little demo. I have a demo of my tuna tin. This is my tuna tin. I have it attached to a dummy load, a 12-watt dummy load. Got the 16-volt 18650 power supply hooked up and a key. If I press the key, I get 12.4 volts. I'm going to do the math to determine what the power output is. Anyway, the encoder is set right now for 100 hertz. As I turn the knob, it moves by 100 hertz. If I push again, it goes to 10 hertz steps. If I push again, it's 1 kilohertz. So I'm now back to 7040.00. Anyway, that's my tuna tin. It doesn't look, it looks different than the ones you have because I got the first version of the board, and I had to do some strange wiring to make the display and the clock generator work. And then the encoder didn't work, and so what I did there is instead of doing some rewiring, I just changed it in software. That's one of the great things about a software-controlled radio, is that you can do things in software that you used to have to be forced to do in hardware. So, and of course, the goal these days is to eliminate hardware and replace everything with software because it's so much cheaper to make changes and easier to make changes. You just you do it in a text editor, you recompile and upload to the processor, and off you go. That happens with my car. Frequently, about once a month, I get a software update on my car. Anyway, that's my tuna tin and video. Did you all follow that video? Did it work at all? I mean, I
Yes.
was having trouble playing here for me.
No, it was good.
With the yeah, it was quite shaky and broken up. I'm not connected to Zoom, why it runs fast and fine and smoothly. So anyway, that's about all I have to say about the Tuna Tin S. I am not a CW operator. I can spell CW, but I can't actually do Morse code and do a QSO. But a number of other people did. The author of the article, the designer of the transmitter, Bob Fontana, he actually had a QSO at 600 milliwatts with a ham in the Canary Islands from his home in Maryland. He also set up a sked with Carol to try to have a QSO with Carol, and Carol was able to hear him with an RST of 229 as I recorded it, but he couldn't hear Carol. And that's probably because of the antenna situation. I don't know if Carol's had any other QSOs. I know that John Kim built the Tuna Tin, and he had a QSO with a ham in Oregon, and also with a ham at Santa Clarita, which is in the Tehachapi Mountains, near Six Flags Magic Mountain. And if there are any other QSOs, I don't know about them. I know Carol probably checked out Half Moon Bay. I think Half Moon Bay heard her signal. And and maybe the reverse beacon network. That's
Yeah.
what Bob
I worked
Fontaine
I
in
worked
the
a
article
ham in
said.
British Columbia. I did work British Columbia with it.
I was just going to ask you if you wanted to take over and talk about it. Yeah. So British Columbia is the best at this point. Yes?
Yeah, that's the best for me so far. But honestly,
Good.
I haven't tried very much since then. But conditions are improving, and I think we're going to get some better distance.
Good. Yeah. Anyway, that's about it for the tuna tin that I have. Does anybody have any questions at this point?
Yeah, those QSOs were made on 40 meters or what band?
40 meters.
40 meters. Yeah. All
Some
of
of
them.
us have built them into these little
Um,
enclosures. Really neat. Little plastic enclosure from Top Plastics.
Yeah, if you join our DIY radio group, why you would follow that, and there are all kinds of images in the photos folder. We have files in the files folder. So I think 21, according to Phil, why 21 people got boards. I don't know how many people have built them. The people that have built them, or some of the people anyway who have built them, have told us about it, but others have been quiet and maybe haven't even started yet. What we want to say is, let us know and we'll do everything we can to get your rigs built. If you have problems with them, you can hand it to us. We can meet at the library and try to diagnose the problems and get them going. But
Bob, Carol and I have been playing around with some design enhancements, and we came up with a couple of circuits that allow the tuna tin to become a full 5-watt actual QRP rig. So there's a lot of experimenting going on out there with tunas.
Yeah, I was going to get to that. And John Kim, I understand, is looking at adding a keyer to his. And I would like to get a receiver to work with it myself, but I haven't achieved that yet. Anyway, any other questions by anybody? We don't have any plans to produce any more circuit boards unless, another half a dozen people spoke up and said they wanted to build it. Why, we would maybe make an effort to do that. Okay, if there aren't any other questions, I'll move on to the tiny SA.
Well, first, I just want to say thanks very much to Phil and Bob for the effort put into organizing this project, because it is for bringing a lot of satisfaction to many of us, and it certainly is worth the while.
Yeah, well, we've had a hell of a lot of fun with it ourselves, taking an idea and turning it into a reality. And then we were actually shocked that we got 20 some people to express an interest in building it. We thought, the age of build it yourself was, kind of considered something out of the past. But Phil has said, rightfully, that this is actually the golden age of do-it-yourself electronics. I mean, it's never been better than this. The components that you can get, the tools that you can get, and the low cost of it all. It used to be enormously expensive to build a transmitter when in the 50s, you had to have giant power supplies and everything, and a bunch of vacuum tubes that sold for more than what some of the transistorized radios sell for now.
The other big thing too, Bob, is the availability of information. This whole internet thing has changed the complexion of our world.
Absolutely. You don't need to go to, electronics engineering school to learn everything you need if you're, hard-headed enough to read, study, and put it to use. So I definitely believe in interleaving theory with practice. And somehow I learned through my fingers as well as I learned from books. So.
The technology has advanced tremendously. This little box here that has this synthesizer, frequency synthesizer, that little the 5351 only goes for like $4 or $5. Now, back in the 1970s, I built a frequency synthesizer. It was called the GLB synthesizer. Some of you may have heard of it. It was used with 2-meter FM radios, which back then were all crystal controlled. So you were actually able to build a synthesizer that would allow you to dial up any frequency on the 2-meter band. This was amazing to do this. Well, that synthesizer kit cost about $200, and it was a box filled with all kinds of discrete integrated circuits and about 2 or 3 different boards in there. It's amazing how cheap the price is right now to get so much better performance, and it's just I mean, it's instant gratification. You could send away to Amazon and you'll have it the next day. So it's like Bob says, it's really a paradise now for people who would like to try and do some building. It's really easy. Although Fry's is gone, you just have to depend more now on mail order to get your parts.